This video has chaptered segments, and the first coming up is feedback and thoughts on the build, the parts, and the experience using them. Consider it a mini review of the project. After that is the build itself and commentary during. Link is in the description to some extra information on the wiring for this project. This video is mainly for reference and feedback for anyone that's either considering such a project, such parts, or curious about what this kind of build can look like. This is definitely the largest one-wheeled board I've ever put together since I had not yet done a big tire extended rail GT project yet. These days I'm mostly interested in projects that focused on clean aesthetics, tested approaches, and sturdy, reliable results that I feel comfortable handing off to a friend or colleague. It's why I don't really bother with things that, in my opinion, only serve to be fodder for big number, hypey social media posts. More often than not, that kind of project comes back to bite me a year later, and I'd rather build things once and have them last. That all being said, again, this video is chaptered, so feel free to jump around if there's a particular reference point that you're looking for. Also, I do appreciate your viewership as always, and I very much appreciate you paying attention to this now sponsor segment coming up now. By the way, this video is sponsored by me. My shop, The Board Garage, is a repair and custom hobby shop that mostly works on board-shaped electric rideables. Through that work, we're able to inform both the content that is published and, maybe more importantly, the products we make and sell. Product reviews presently and going forward will only be done on products that are purchased, and the channel no longer takes free products for review or offer affiliate codes or links for reviewed items. So if this video or any other video has been helpful, please consider supporting on Patreon at the link in the description, or by becoming a member of the channel. Thank you for your time. Alright, now this board is obviously a VESC-based build, and it's built on TechRail's extended 357 GT rails, and so it is very large. It's bigger than the GT S, it's certainly bigger than my own board, which is just about as big as an XR, and it's running on most of the Fungineers GTFO kit. I don't know if by the time this video gets published, if the LEDs will be available. I have an early version of them in here, and I've been giving some feedback, and there's some points of frustration, and so I'm just gonna, before I get into the rest of this, because I will cut in the entire build for the most part, and I just want to get sort of a half review out of the way of using the kit. Now the Thor itself I have experience with, it's in my board. There's a previous video on this channel of a one-day build for my friend and colleague Russ, who his board now runs on a Thor using the complete box. Generally speaking, the Thor runs really well. Performance-wise, it performs well. It is a noisy VESC. My board is literally noisy, especially when the lights are on. And this one is slightly less noisy, but also kind of noisy. This particular board, it's the first time I've encountered this. The tail light, whenever the motor is moving, gets all glitchy. When it's standing still and you're not touching on the sensor, it's fine. But when you move, you can kind of see it starts to glitch out. And I don't love that. I haven't yet found a reliable way to resolve that. Like I said, it doesn't happen on my board. It doesn't happen on any of the other XR builds that I've done with the Thor and the complete box. So I'm assuming the LEDs in this have either no filtering or no added pull-up resistors on the data line. I don't know what it is, but that's kind of bothersome because getting into a battery box is really obnoxious and time-consuming. It's not something I want to do often, if at all. So that's a point of frustration. Also, the LED kit was meant to kind of all plug into the light bar bit here. None of that worked, and so I had to do some rewiring, which is fine. It ended up technically functioning, but that was also a point of frustration. And this is all stuff if you keep watching and you see the assembly bits, it'll show up in there. And also the lid for the GT box, the front box, I had to modify it because the Thor sits a bit too tall because it's on a heatsink, and so I had to modify that lid. And I had to modify the box itself to fit the Superflux connector. This is using a Superflux V2 high speed, and it mostly went well. The parts generally went well together, aside from the things that I just said. And my last complaint is that, so these axle blocks. One of these, I believe it's this one, but either one of these doesn't have the screw holes tapped for threads for the cable cover. So only one of these is going to be able to have a cable cover on it. I believe it's it's this side will have the cable cover on it. It's the side with the power cable, which is fine, but the side with the motor cable, I can't put a cable cover on it unless I like stick it on or something, because there are no screw threads, and I didn't notice that until I put the motor in the board. So at some point when this thing gets a tire change and the motor comes off, I could probably just tap threads, but it's a little bit annoying that one of these blocks doesn't have any screw threads. And so that is bothersome. Also, where this sits, the status LEDs are not that lined up with the window. So they could stand to be shifted. If you're looking to the nose, they could stand to be shifted this way. So that's mildly annoying, because it's, if you look in from this angle, you can see an LED down that way. And so it's going to appear as if the battery meter is showing a lower battery level than it actually is, because the LEDs are just kind of put in that direction. And so that's something. Is it the end of the world? No, but you know, you have expectations, and this is why usually whenever I make something for a colleague or a friend, I like to spell out every possible shortcoming or thing that the device cannot do before they agree to give me money for it, or they agree to have me do it for them. I like clarity. Clarity is important. And there were things that were not clear about this before I went into it, and that's kind of frustrating. So, that being said, the board did come together, and the Thor is a decent performing VESC, and so that at least is good. And this is an 84 volt 20S system with an adapted charger running in the back, topping off the battery. And then, oh, it also has the very, very large Burris 7-inch wide tire. So yeah, this is so far the biggest board I've ever put together. And there we go. So if you're interested in how this came together, go ahead and watch the rest of the video. It's going to be a pretty rough cut of everything just being pieces, and then the pieces coming together into a board. As always, I appreciate your viewership. And with that all said, we'll get on to the build. Okie dokie, artichoke. So right now I have this whole thing on the bench, and this particular board project is for a friend and local, and it is going to be built into a GT frame. So I usually work on XR frames. I prefer them, but you know, if you want a GT shaped board, then you want a GT shaped board. So there you go. And what I'm going to use for this are parts from the Fungineers GTFO thing. I don't know if it's a kit or if it's fully realized as an actual product that they're offering. I don't know. I'll talk through the parts that I have, the parts that I'm using, and the parts that I'm not using. Now, I'm not using a GTV kit for a couple of reasons, but one of the reasons is that this is not going to use a stock GT battery. It's going to use one of my batteries, which is a 20S 2P. This is a GT meat pack. And so it's 84 volts, and the GTV kits from Floatwheel that I've seen photos of, people have installed, and that a couple of locals ordered and installed, they're all using 80 volt components. I know at least the input capacitors are using 80 volt components, but you know, running that at 84 volts is probably not a good idea. And so anyway, the Thor is designed for up to 20S, and so we're going to run it at 20S, which is 84 voltage input. So that's that. And also, Fungineers has a BMS. I did get one, and this is meant to go with a stock GT pack. I'm not using this. I did a quick smoke test. I plugged it in, I charged with it, I discharged with it. It didn't kill me, so that's as far as I've taken it, but I'm not using it in this build. And so there's that. This build is using the Thor. It's the same VESC that's in the board I'm riding now. And there's a previous video of a one-day build on a big tire XR platform type thing. And so same thing, Thor. And the motor that's going in here is a Superflux, because that's what they meant this stuff to work with, is the Superflux motor, not a stock GT Hypercore. And Fungineers sells these adapter blocks to adapt the Superflux motor to the GT rails. And these appear to be just, you know, aluminum in a bead blast finish with a clear anodize. Nice, fine. I do have these also. It's the same thing. These are pub blocks, but these are also aluminum, and it looks just like a regular satin machine finish with a black anodize. So given the color of the rails, which I think are like a bright teal or whatever, probably gonna go with these because I think that'll just sort of work better than the black blocks. I got these from Weston at PEV Dispensary, along with these bolts that I am gonna use. These are custom GT bolts for the Superflux. And I got these from PEV Dispensary. They're about, I think, 1 centimeter longer for threading through this, through the rails, through this block into the axle of the Superflux. Since on a GT, it's 2 bolts per side and not 4. On an XR, it's 4 bolts per side, 2 through the carriers into the axle, and then 2 from the rails into the carriers. The GT is different. So this is a bench test battery. Let's zoom back out. And this is the battery that's going in it. This is a 20S2P also, but it's the smaller one. There's a bench test version of my regular battery, 20S2P, and I'm just using that to bench test. I bench test everything as much as I possibly can. So what I've been bench testing so far up to now are just the LEDs. And so I don't know if they're for sale yet. The ones I got, I assume, are just early versions of them. And it kind of highlights my current opinion that nothing in VESC Onewheel is plug and play. Period. I know products are offered that way from various vendors, and some things are pretty close to it, but I mean, just philosophically speaking, if it's running off of VESC, it's not plug and play. There's always going to be something that you're going to have to do, learn, redo, troubleshoot, going down the line. Plug and play is not really a thing. It's a cute marketing phrase, and that's just how it is. But when it comes to in practice, plug and play is kind of a bit of a pipe dream at this point. So there's that. That being said, the LEDs are slightly different from what you would do with like a Thor complete box on an XR. I did get the headlight and a tail light and this unit right here. So it's all plugged in. So I can't just move stuff around really quick because the stuff's energized. But here's the Thor. And here is the status bar LED that is meant to be plug and play-ish, meaning you're meant to use it with the cable and this 8-pin JST GH connector, and it's supposed to go there and do pass-throughs for the button and then send the data to the rear for the rear light. I could not get it to work, period. On float package or refloat or whatever, I could not get the tail light to work, and then it kind of made all the rest of this stuff sort of weird. And so I did my own work, which, it didn't take forever, but it took time. And it also highlights the fact that if you're someone who's, kind of under the impression, I built a couple of VESC Onewheels and now I can do it for other people. I mean, maybe for a while until you get to a point where you kind of run into a snag that you have to just fix yourself. I'm doing this for my local friend and colleague, but I told him I would give him a functioning device, not a pile of parts that kind of work. And so when things don't work, that's my problem, and I have to fix them. So that's what I've been doing with the LEDs thing. So this does work on its own. The headlight plugs into the Thor on its own, and that's fine. But getting the taillight to work, it's been a process because there are no pins marked on the actual LED bars. There are no pins marked anywhere, not on the Thor, not on anything. And so I have a diagram here of the Thor's pinout, which is great, but I don't have a pinout of anything else. So using the meter and probing around and checking continuity from connector to the pins on the LED die, I found where 12 volts and ground are, and then I kind of just guessed where the data goes. I guessed right the first time. So I found where 12 volts and ground goes, and I guessed that data in was right next to it, and that worked. And then I checked the other pins, and they don't work, so it's that one. And so I do have it working. So I have the LEDs working. most of the time, I'm assuming it's a firmware or a package thing, but sometimes I turn this on and it doesn't actually like boot up the LED control properly. So it takes forever to boot up, but so far it seems most of the time it works. So that's good. So, okay. So I got the taillight to work. It's doing the Knight Rider animation, which is what I set it to do. The headlight does work, which is great, doing the same thing. This is 15, that's 15. The status LED is 10 LEDs long. And so that all seems to work just on its own. And so since this is going to be using a large tire, I'm going to have to use an extended cable. So I'm just going to make a new one. But now that I have this working, the plan is when I redo the cable, I know which pins here. And this is what I did with my XR build. Just take these 3 pins through the new cable, put them in the back, and then those wires will trace where they're supposed to go with 12 volts ground and data. Another thing I ran into, which I did not know, was that since the headlight has these COB LEDs, it's got 4 of them that are just bright white, they are very bright. And if you run them at 100%, they will overheat in maybe like 3 or 4 seconds. And so you can test that even without it running, because you can just set the forward behavior to be just solid color and set it to just full white. And so so far I think for it to be able to run for a long period of time, 65% brightness seems to be okay. And so that's what I'm going to set it at. So we'll set it to solid, and we'll set it to full white RGB. And so these are bright. These are very bright. And this is at 65%. And these, after about half an hour, will be pretty warm. And so part of that testing is leaving it here for like 2 hours and seeing if this or the wiring gets warm. So far, it hasn't. But if you run it at like 100%, it's really bright, insanely bright. But very shortly, you will start to see the CO. There we go. They're not doing so hot. I mean, they're doing really hot, but they're not doing so well. And so we want to bring that down to, let's do 60%. And now they're off 65. Now, oh, there we go. So they cooled back down and now they turned back on. That's fine. 60%. Okay. So right now we're going to leave it at 60%. 60% was the brightness for going forward with the headlights. That seems to actually only ever get warm and nothing more than that, which is still pretty bright. But that's something that, you know, you have to test it because, you know, that's where we're at now. The next thing to test is the Superflux motor with this adapter and the Thor. And I'm just going to clamp the motor to a rail, clamp the rail to the bench, and then spin it up and see what the values look like. Make sure that the Hall sensors are detecting. That way that I know when I actually install this motor panel mount into the box and I'm using it with the motor I'm going to use, it will actually work, and I won't find that out after I've assembled the board. So that's all fine. And that's the next thing we're going to do. Once I get that worked out, I'll just check over the VESC assembly, and then I'll start putting things together. All right, here we are with the motor. Can I zoom out anymore? No, I cannot. So this is a Superflux V2 high speed with the Burris 11.5 by 7 by 6 tire on there, big tire. And so we are going to check the motor and the adapter. So we're just going to do real quick motor detection procedure by connecting to the Thor and then disabling the package and Skibbity Rizzler, and there we go. Okay, fantastic. So let's just go ahead and do that. And all we need to do is just make sure that, like I said, the cable and the adapter and the wiring is correct. And so this should come back with some sort of values. If they look normal and it's detecting Hall sensors, at the very least, I'll know that the wiring is correct. So we'll do the use. Restore defaults. Sure, why not? Doesn't matter. I haven't set anything up on this yet. LEDs are doing something. I don't know. Probably should have selected no, because now I have to wait for reasons. All right, EUC, large outrunner, 30 motor poles, sensorless ERPM 2000, and then we're just going to do all the rest of that stuff, and then we are going to see if we can get 20. Okay. I hate this. Oh, I'm recording. Okay, just put in some regen and current max values that are more or less decent just for the sake of testing, and then we should be okay. Let's just pray that this works. Okay, that's a good sign. Also a good sign. So far, so good. Okay, let's see. Hall sensors, temp comp. The FOC values look normal. Okay, so this is good. That means at least, at the very least, the wiring is correct between the cable and the adapter and the pins and all that stuff. So fine, fine, good. That alleviates a little bit of anxiety. This clearly runs the motor. Fantastic. Okay, now we can move on to the next step, which is, I don't even know at this point, probably modifying the porthole in here for the motor connector, and then modifying the, what is it? The charge port wiring to go to the BMS, because it's 3 wires, I only need 2, and yeah, so there you go. Now we've got the cable done, and turns out there is enough, mostly enough, well, there's enough sheathed length to run the existing stock GT wiring cable between both boxes for the extended rails and the larger tire, which is fantastic. And since I had to redo wiring anyway, or rather augment the wiring, I just extended the data wires, and then that's fine. So in the rear, I did not have to extend anything, so I just selected the wires I was going to use for the taillight and the CAN bus. Charge port on a GT is in the rear, so the cable doesn't need or have those wires. Fine. And what we've got here is we've got 2 things we need in the rear box. The BMS, which is an X-Lite, and so the CAN bus wiring is 4 wires for 5 volts and negative to wake it up, and then CAN high and CAN low. And so for that, luckily in the existing wiring cable, there's a blue and a white. I like blue and white for CAN. That's just a preference. White for CAN high, blue for CAN low, works for me. And then I use green for the 5 volts and brown for ground, and that's fine. I did, in the front, I spliced slightly different colors just so I knew what headers they were going to. But the point is, as long as the wires trace and you can kind of keep track of where they're supposed to go, it'll work out fine. In the rear, the stock taillight used these wires, and so I just depinned and repinned, and so whatever. So the taillight that I'm using black, orange, and yellow. Black is ground, fantastic. The orange is 12 volts, and the yellow is the data. So that's good, and then that traces up to the front here, where I did splice on a little connector, or rather an extended wire, just to make sure that the GH connectors were going where they're gonna go. For the CAN, I did the blue and white again. Brown went to black for ground, and green, I just kept green for the 5 volts. And then this goes to the tail light header over here. Can you zoom in, does it matter? And then this went to the tail light header over here. Fantastic. I'm not using the XT60 yet on this wiring thing because I didn't put the XT60 on it yet. So we're just doing that on its own. This is the battery. BMS is connected. And so this is a flat kick foot pad. It's a stock one that's sitting in the box. So I'm going to test that with this and we'll make sure that that works. So now everything's connected and we're going to test it and turn it on. The package should be disabled still. So yeah, it's disabled still, but can wake up. This worked. So let's connect to the BMS and change those settings. So that looks great. Temp sensors, fantastic. All right. And it woke up the BMS with the CAN 5 volts. Fantastic. Let's disconnect. Let's connect to the Thor and let's reactivate the refloat. Now I can see already the taillight is getting power and colors and it's doing like a pulse animation. So at the very least, the wiring appears correct. So that's great. We got all these CAN devices. Let's go to the Thor, wait for this to populate, and then we can sort of go from there. Here we go, refloat config, specs. Okay, there we go. So that is doing something. I don't know what that's doing. Oh, I know what this is. I think when I redid the motor configuration, that was all off. But the headlight is working and the tail light is working. And so that's a good sign. Let me just check. Motor config, additional info. Yeah, I know what that's all about. Oh, it's probably because I had it on a test pack, and so it was near full, and this is, this should be higher. What if I do that? Oh, interesting. Okay, but at 20S, all right, so it's working. It's just for some reason the battery meter on this is way more conservative because the battery here, let's see what we got here. What's the battery? Oh, okay. So yeah, so this is still technically at nominal, but it says nominal is like 9%, which is fine. Let's take a look at the BMS tab. All right. Every part of VESC has a different opinion on what battery percentage and levels are. So this is currently at 3.46 volts per cell, which is not empty. 3 volts would be empty, but I guess in fairness, if 3 volts is empty, whatever. So that's fine. This is a very conservative gauge. So if you're at 1, my board's probably like this too. In fact, now that I'm thinking back, yeah, out of the 10 LEDs at this level, it kind of, yeah, it's a, either way, this functions. The tail light, fantastic. This works, and then we'll go ahead and press and hold. This should now turn off, and then give it a minute, not a minute, and we'll turn it back on, and then we'll test the Footpad since the full package refloat was reactivated. Let's turn it back on. This turns back on. Let's give it a second to boot. Okay. So is it doing the thing? No, it's not. This is doing the thing. This is so frustrating. Why does it do this? Why? Why? And on. And on. 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 And on. I hate you. I hate you so much. Okay, disable package, re-enable package. Anything? No? Nothing? All right, next clip, firmware thing. Okay, I don't know why it does this, so I'm just going to reflash the firmware, but I turned it off again, and I turned it back on again, and it seems to have booted up correctly. So I'm just going to reflash the firmware because fuck this. Fuck all this. Okay. Either way, the firmware flash will happen, but fortunately also we can see that this works and it lines up. So that's, no, wait, no it doesn't. This is supposed to sit here. Okay, so that's something I'll have to fix. And you know what? I will just fix that now. So let's turn this off. Take this adapter off. So this adapter is pinned backwards. Just checking that I'm not crazy. So what we'll do is, where are the tweezers? Here we go. So center stays where it stays. And then the ADC pins are on the sides. So we will, which one's pointing here? This one. So we will just unpin these. Okay, bend that leaf back in. So we are going to just unpin these. And sorry if this is getting blurry, the focus on such a tiny part is difficult. But either way, what we're doing here is we are unpinning the sides and then just swapping them. So blue will go here. Okay, bend the leaf back in, that way the crimp can catch properly. And then the white wire will go in here. And there we go. So we've swapped those. We'll reconnect this. Okay. And now we'll turn it back on, let it boot. And now the LEDs work fine. And this works fine. And now the LED indicator for the status bar lines up with the correct sensor location. So that's that, which means that barring the firmware reflash, this is essentially ready to go together. I already carved out the little roundness part there for the Superflux motor connector adapter, and all I have to do is put the cable back in, cut the rear wire short for the discharge, and then XT60 that inside the rear box. Then I can start laying the components in and doing wire management, putting the LEDs in. Putting it together is what we're going to do now. So real quick, off camera, I'm just going to reflash the firmware, and then we'll do all the other stuff I just said. Now, moving on, we've got the Superflux motor connector in here, and it is sealed in with some silicone just around the outside where the O-ring engages to make sure all those gaps are filled. Put in the Footpad connector right here. And regarding the cable, I'll have sort of detailed pictures of this as it goes together on the article that I'll do, and then link that in the description of this video. But there is this, which goes to the COM port, which is the CAN input. Then there's this, which is going to the tail light header. And then that leads here to these wires, which go to the actual tail light. This has been modified to go into the BMS. And then this is, of course, the CAN bus that's going to go from the rear, where the BMS is, to the COM port in the front. So now we can actually start installing things. And the things that have to go in is the status bar LED. I put some fish paper on here just so that when it's screwed in and it sits against the metal posts that are sort of raised. It won't be like bare PCB or that ground plane just up against the metal posts. Got to put the headlight and taillight in. These boxes thankfully still have the little screw posts in there, thanks to One Stop Board Shop, which helped me source this. And then we're going to go ahead and mount the heatsink block with the Thor. Once that's in, I'll connect everything in the front, and then we'll do the wire management and then close that up before we do the power bits in the back. Now for these screws, it's good to thread lock screws in something like this where it's going to be jostled, subject to impacts, vibration, all that stuff. I use this for a lot of screws where Loctite, like blue anaerobic thread locker, isn't going to work or shouldn't be used because it might degrade something. This is Vibratite VC3. I'll have a picture of this also. It's a resin-based thread locker, so you don't actually put it on there and install the screw. You put it on the screw threads, let it dry, and then it's similar to those screws with like a nylon patch on it, so it'll engage the threads and sort of, you know, hold it in place. It's like that, but you put it on the whole screw fastener thread thing. But you put it on the entire surface of the threads. It dries kind of into the threads, and then it is a thread locker. It can be moved, it can be adjusted. Sometimes if the screw is large enough, it can be reused. Smaller screws, it kind of just comes all off when you remove it, but either way, it is a very good thread locker, especially for slightly smaller screws. These are all M3, I believe, but yeah, for things where using something like a regular Loctite 242, 243, where it could damage plastics, the Vibratite VC3 is great because it doesn't corrode plastics. It's, like I said, it's just a resin. You put it on the screw, it dries, and it's like a little rubber layer that helps engage the threads, so that way when you install it, you do get the thread lock on that screw without possibly damaging any plastics from it. So there we go. The status light is in there. The headlight and taillight, so the headlight uses a Phillips screw for some reason, so that's fine. Yeah, it's a Phillips 1. So this should go here in that area. There's a little holding slot that secures that. And drop the screw. And presumably that would go there and secure it in place. And we'll do that until it stops. And that feels secure. Okay, great. So headlights there. The rear has a regular Torx screw, not a 5-point star. So which one is it? I'm gonna guess T8. Yep, T8. So the rear, so the tail light is a T8 Torx. Okay. Interesting. Oh, it's, yeah, because this is threading into plastic. The headlight threads into metal. Okay, now this is the wrong way. Oops. It's this way. Fantastic. And then we'll get that. So I like to drop everything all around and possibly lose screws. Usually, you know, before I get everything right, I'll go ahead and just drop everything all over. Okay. Not too much because these are plastic threads, but that seems secure. The LEDs do line up. The LEDs do appear to line up. Great. So that means now these 3 screws have the Vibratite, the VC3 on there already. And so we're done with the Torx. Put that back. Put the hex right back on there. And then we're going to grab the Thor. I'm going to go ahead and grab the Thor and install it into the front enclosure. The front enclosure. Now I am going to put a tiny bit of thermal paste between this and the box. I don't think it actually needs it for heat transfer, because the Thor runs pretty cool, and that heatsink is pretty substantial. But, you know, having just metal clamped to metal in a box like this when it's such a large surface, having some sort of material as an interface may or may not, and this could just be entirely superstitious, may or may not help with the vibration, because having hard surfaces, metal to metal especially, vibrate against one another, or hard plastic against metal, you know, that's where you get some weird vizh noises that I don't really like, because it can be unpleasant, it can screw things up. And so having a little bit of the thermal compound under this heatsink between this and the box, see right here, it's no longer rattly, and so it's got a little bit of schmudge to it, and so we're going to keep that there. So that way, once this is secured down, you have a little bit more buffer between hard surfaces. So these screws are countersunk, so we'll start the screws in the threads. Then once they're all in and all the screw holes are aligned, then we'll go ahead and thread them the rest of the way. So that way the plate lines up the way we want it to. And these screws, again, have the VC3 on them. So you can feel a good amount of resistance of them going in. And so that is encouraging. So these are M3, so you don't want to really do too much tightening, because they're tiny screws and you don't want to damage them. Okay. Just like a hair past snug. There we go. And that feels solid. It feels like really planted in there. And the goal is that, you know, this is secured properly. Screws are thread locked, thermal paste under it. You know, you don't really need extra heat sinking going on with the box, but it's there, and like I said, sort of a physical vibration buffer, which couldn't hurt. So now it has to be connected, and so we'll have to do wire management. To be perfectly frank, these could stand to be shorter. However, we can manage it because we do have space here, and so let's start doing that. So sometimes what I'll do for wire management and anchoring is I'll take these electrical anchors. They're the ones that you are meant to run zip ties with. And so, you know, I got zip ties, and I take the foam adhesive, the double-sided adhesive off, and I'll replace it with VHB. It's a stronger bond. Wipe down the surfaces with isopropyl alcohol, and give them some time to bond and cure. And then that can help be an anchor point if you're doing wire management. Usually I'll do that for like thicker wires, phase wires, power wires, stuff where it's, you know, it'll go where you want it, but it'll also kind of come out from where you want it and then give you a bit of a hard time. So I'll anchor those down. Usually small wires, data, stuff like that. You don't really need to do that. So I'll do the larger wires first. And so I'll just take some painter's tape just to hold these out of the way so they don't get damaged or pulled by a large wire. So just keeping those out of the way, and that way I can focus on this. Now I have an anchor up on the side of this box. I'm going to put another one right there, and I'll probably put a third right there. So that way when I get these connected, I can sort of route them in a loop, and that way they'll be held in place and not bounce around. So I'm just gonna, I've already cleaned all these surfaces off with the alcohol, and so I got one anchor with VHB. I'll do another, so I'll take this foam off and go ahead and VHB it up. Generally, my goal with wire management is to sort of keep things out of the way in terms of them hitting components that I don't want them to hit if this board's being jostled around. Ideally, they shouldn't move. And in the case of the phase wires, trying to keep them away from other stuff because they can heat up. And also not creating areas where things can get pinched or overly compressed or damaged when you put the lid on. And so that's generally what I'm looking for. And in addition to that, sort of keeping it tidy, but in a way that you have an exit plan. If you need to replace the VESC, if you need to fix a wire, you're able to kind of work backwards, remove things, and still have decent access to things. I find more often than not, if you plan for ways to repair something, just by virtue of the universe, the chances drop a little bit of you ever having to actually repair it. So that's something. So there is the vent here. I'm not going to put this on top of that, want to avoid it. So we will adhere that there. And then there's a big old flat spot there on that heatsink plate. And I'll stick one right there. Probably at an angle. So I'm going to save that one for last because that might need to be at an angle. And so this could go like so, and these could go like so. And then if that's the case, I might not actually even need that other anchor. I could probably pry the one off that's on the wall. You know what? No, I'll use the one that's on the wall. Yeah, so that's what we'll do. So I'm going to grab some heat shrink. We're going to go ahead and put these together, and then we're just going to go ahead and kind of loosely anchor it. I'm not going to keep it super tight there, so that way there's a thing where it's fighting itself. And here we go. Okay, phase wires I use, because most of the phase wires I come across for this stuff, it's usually on 12-ish gauge wire with 4mm bullets, more or less. So I use a 6mm heat shrink, and I like getting it in the blue, yellow, and green because that's common phase wire colors. Yellow, blue, green here. Fantastic. And that way I can sort of mentally match them up, and it's, you know, it's something. Is it necessary? Certainly not. But especially on the older Superflux motors, the V1s, where to change the tire, you have to take the motor off, and you know, you can alter the connection order. What I'll do is I'll take this blue heat shrink, and the motor wires have the colors on them, and then I'll mark them and use that as sort of an identifier. In this case, it doesn't matter because we are using the connector. But still, it would be nice to just have them sort of match up. All right, so that looks like that will sit decently. So you know what, I probably will use the anchor. I'll hold these there, and then I'll pull this here, and then I'll pop those there. That way, when the sensor connector comes out of here, it can just come right here, and it won't kind of interfere. I don't know if that would actually matter, but it will make me feel better. This is unplugged. Why? Because of course it is. There we go. There it is. All right, good then. So it feels like we've kind of got these trained almost where we want them. It kind of seems like the adapter has a thicker strand, like a lower strand count, slightly thicker strands than the wiring on the Thor. So that's probably why that is more apt to take some bending and stay trained in that bend than the other wires. But that's fine. This will work. And so fortunately, we can run the zip tie right through there, grab it right where it's heat shrunk, and then that should be pretty much all we need there. So do that, run it down. Here we go. Catch it at the bottom, pop it up. Yeah, I don't want to do the whole thing. I don't want to do the whole bundle there, because I don't think we need to. Okay. And you don't need to, I don't need to cinch this down crazy tight. It's really just to keep it in place. And you don't want to crush anything or do some weird stuff to the jacketing. So when you're using zip ties, if you choose to use zip ties, there are a couple things to keep in mind. Obviously, don't cinch it down so it's so bad that it's cutting into wire jacketing, especially for smaller wires. That would be bad. And if you want to, you could kind of run a single layer of like harness tape. So something like this is Tessa tape. There are a couple forms of it. You could probably do like one loop and then zip tie over that to kind of protect the jacketing if you want. Sometimes I do that, sometimes I don't. It kind of depends on the situation that's happening. You know, if you got a pretty hefty wire management situation and you don't want to keep it cash, you can just, you know, you can protect the wires with the tape, and that's fine. So I'll stick that there. We're going to plan to go here, and so this will go there. That is another surface that I did clean, so that way that adhesive should stick. I'll give it a minute to sort of bond into the surface. Adhesives tend, VHB especially, tends to bond really, really well to anodized aluminum surfaces. So that's something to consider. At least that's what I think. I read it on one of the bits of documentation for 3M VHB, and I think after reading that, my mind was primed to just see it everywhere, and so now I kind of just believe it. I haven't tested it, so that's just something I think. Okay, now we have an anchor here, which we are now going to use to manage the power input stuff. And it looks like that would work, because it would keep this here, run it under there, and it would keep the input power lines under the power button wiring, so it doesn't kind of mess around. Because the power button on here, the wiring is like dirt thin. Dirt is not thin. It's very thin. I don't know if it's like 32 gauge or something. It's pretty thin. So that's something to also be aware of. So I'm going to try to go under that. Okay, bring it up. So we got it around all the wires we want to go around, and we got it to catch. So we're going to use this opportunity to have this sit where we want it to sit in a way that's not going to strain or offend the curvatures or the tensions of the wires, and also leave us some kind of exit plan should this have to come out and be repaired or fixed or whatever. So, okay, so far so good. We're doing okay here, which means now this sat there. We can do that. We'll do one more here. And what are we doing? Like this? Yeah, that's what it was. Which means once these are in place, we can go ahead and just connect all the other stuff, the smaller bits. So the sensor connectors, the lights, all of that. So that's fine. Good. So that's good. This is fine. And now we can do this. So as we're doing the rest of the wiring, we've got the tail light, the headlight, the status light. Kind of have to keep it as low as possible, so not just sitting floating on top of the Thor, because we do have to contend with the lid And the lid has these ribs on it. These things that kind of bring it down low. It's got all this silicone on it that I'll have to reapply anyway, but either way, it has, you know, this LED window, and then on it has a bunch of stuff that, you know, kind of lowers the height of the enclosure. So as far as the small wires go here, so long as nothing is under tension, this isn't really pretty and I don't love it. I might bundle this just to kind of keep it in place. Let's see how this goes here. But the goal is to make sure that A, stuff is not under tension, and B, it is clearing the lid so when it goes on it, nothing's being pinched, which would be bad. So especially against something sharp and metal like these USB ports, you don't want something pinching on there. And so, you know, some of these might need a little bit of help there. I might run, you know, I'm going to plug in the hot glue gun. I don't trust this lid. So I am going to run a little bit of strain relief on some of these wires just so they don't get too badly bent inward. I'm going to take a look, see how this sits. Yeah, this stuff gets pretty low in there. So I don't want it to, you know, do too much violence to the connectors, as it were. So let the let the glue gun heat up, and then make sure I can clear this. I should be able to keep things where they are without having to bundle them too much. I think once the lid is on there, it's probably gonna do it for me. Like I said, it's gonna be held down. I don't think anything's gonna cross over. So, yeah, especially this one that is coming from the status light. One of these wires is, I guess because this is an early version, it's soldered to the end of an LED die, and I don't love it. These things are way fragile, so I'm gonna, yeah, just do a little bit of strain relief on some of these connectors here just to sort of save my mind a bit. Okay, change of plans, because I still don't love how this lid fits with these ribs pushing down on wiring and connectors, so I'm just going to remove these. And so this is just plastic, and there's a cross ribbing pattern here, so I'm going to remove these 3 ribs, make them flush with this, and probably sand them smooth, but I've cut a little bit and it doesn't feel sharp. So that's the plan, is to just slowly go across and remove this bit by bit. I don't think it'll take that long, but it is going to take some time. And so I'm going to try it with these flush cutters I've got, but I do have some stronger ones. Okie dokie, artichoke. So, lid for the box, right. I removed not this rib here, I removed the 2 here and the shorter one next to the LED window. And it seems like that will now have this fit as it should without bearing down on connectors, wires, stressing things like that. And so that means that this can now be closed up and sealed, and we can go from there. Now, we are gonna silicone this a little bit. Got the windshield and glass sealant. All right, so now that that's there, drop the lid on, line it up, and it does just sort of seal in. You can kind of see it through the lid. These screws, I believe, are the correct ones for the front. I like to do the corners, make sure everything lines up. Then we will put the rest of the screws in and then fully drive them down and tighten out the lid. All right, did get some squeeze out after cinching the lid down, and so we will carefully clean that up. Okay, so this is done, and tell you what, by the way, when I was doing this, I did put the rear plug back to normal polarity, so that means that the flat side that's marked positive has the red positive, and the black has the negative on the round marked negative side, and so this is all fine. I did add a little bit of hot glue here for strain relief of these wires and to cover the third pin, and before I do that, I'm just going to connect this, and I'm going to run the power on here and just make sure that this thing still works the way it's supposed to. So let's grab, I'm going to grab the bench test battery because the other battery is still at nominal and this one is closer to full. And we'll check and make sure everything aligns. This is my anti-spark adapter, so that way I'm not wearing out the XT60. Okay. And let's check that out. All right, cool, that lines up. Okay. That looks great. This looks good. And so, oh, there's a screw in here. And that looks great. Tell you what, let's connect, now that we've got this lid on here. And by the way, these LEDs did come on and start functioning, and the package seems to have booted on the very first go, which is encouraging. So that firmware refresh probably did help. All right, let's see, status bar brightness. Here we go. We'll do 75. Okay, that's actually a little bit better. And with the foot pad on it, that looks very good. Okay. I wonder what it would look like at 50% brightness. Oh, it looks terrible. Let's do 100%. Oh, no, that's too much. We'll go back down to 70%. I think that's perfect. And again, this looks great. And the tail light looks very good. Okay. Now we're getting into the battery box here. So X-Lite is adhered down to that shelf with 2 layers of VHB, which smooths out some of that bottom texture, cushions it a little bit more. And I'm doing, very carefully, this is the double-sided adhesive. It's not even really a tape because there's no actual film. It's just adhesive, double-sided adhesive. I use this for tracing balance wires over a pack path or something like that. It's helpful because it's really, really tacky. And so I'm going to use this to hold and train the wires from the front to the back. So on this 20S2P pack, you end up with a lot of vertical space, which I'm just going to pad with some runs of, it's not super dense, it's kind of low, almost low density, with some neoprene. And it's not the high density stuff, so it's got a bit of squish to it, but it's tall enough that once you get the lid down, it will compress. And okay, I'm having a hard time with this. There we go. It will compress and brace everything. And I got fish paper on the corners, foam front and back to help center this and sort of guard this from anything that happens with the lid. And then we just trace the wiring. So on this side, we have the charge port, and this sort of just holds it. And once it's there and settled, I'll do a couple strips of strapping tape just to really hold it. But this stuff is very tacky and holds really, really well. And so I'm trying to do this without getting in the way of the camera. So and there we go. So that goes there, and that makes it to the tail lights. And we have the discharge wires, which will go here and then curve over top. These are always a little bit difficult to deal with because they're so stiff. So you gotta really make an actual corner bend there so it contours. And then you lay it like so. And then next to that is the CAN bus wires. Get these here on that side of it. And then these will just run straight down. Now they don't have to be perfect because, again, there's a lot of vertical space, so this stuff doesn't get compressed. So it just has to land where it's going to land, which it does. And on this, we'll run some strain relief like I usually do for JSTs. And I think that should be it. And so the way I'll usually do it is I'll run it like that. Zoom in a little bit. So I'll run it like that, and then I'll do foam here, here, and then here. And that holds it in with the lid and makes sure that stuff doesn't get pinched. So, good then. Now, can I zoom in a little bit more? I should be able to. Yes, okay, great. So one more thing I do is I'm gonna run a fish paper shelf here and here because the lid does kind of sit right there. There are two locating pegs that go right there, and the lid is aluminum, and it shouldn't interfere because I matched it up before, but just in case, I'll make a little bit of a fish paper shelf. Stick that down in there, and then fold that over here. And another fish paper shelf for the charge wires. They are smaller, so it's not likely that they're going to even come in contact with the lid, but again, just in case. And then that should hold it. And so this is sort of bracing that, and then that will help just sort of further distance this stuff from the lid. And there we go. Now finishing up the battery box here, I did have to move the BMS this way just a little bit, give this a bit more space for the XT60. I probably didn't have to move it over all that way, but it's there now, so that's fine. And so the can line is coming a bit this way. I'll accommodate that with the foam in a minute. And so now we're putting in the balance wiring. The XT30s are in. And so we're gonna run these across like so, and then everything else should be plugged in, and I think what remains is the can. So that appears last. We'll plug it in last, and then we will turn this on, make sure this stuff still turns on as expected. This is a different BMS than before, so it's probably gonna beep. I'm gonna have to set it up again. So that does wake up, that's good. Hasn't beeped, so that's positive. But let's check. Here we go. It is broadcasting. Tail light is working as expected. So is the headlight, and since we have the original battery in it, yeah, it got that little red light there for that. So that's perfectly fine. 20K, wonderful. All right, so check the BMS. This looks good. Excellent. Okay, so this is good. Turn it back off. And then finish up the wire management, lay this all down, and then we will lid this. I did use hot glue on here, just around the XT60 to keep it in place because I don't want it moving. And that is about it. This goes where it's supposed to, and we have plenty of room to run this wiring down. So now that this works, going to secure these JSTs with hot glue here. I like to run it across the joints and between the headers to hold it all in place. So that holds it, and I think that's all I will need this glue gun for, so we'll turn that off, or rather unplug it. And the hot glue along the JST PH headers, when they're connected, it is removable. It's a bit tricky to remove, but it is removable, but it does serve to hold it in. That way they don't kind of jostle out through the life of the device. And so once that is cool, then we can get these down where we want them to be. And I usually grab some Captain tape and run it over the top plane of the battery to make sure that nothing can get kind of stuck over it and pinched. And so this, I'll probably just do a little run like that on top just to cover this over, and then I should be good to go. All right, so we're ready to close the box. Foam is where it should be. It is covering the label, but who cares? And this is held in place, so it should not move. And there are 4 keying pegs, I guess, in the lid. There's 2 ones in the front that go into these slots, and that is fine. And then there are these 2 that sit right here on these corners. So I put some Tessa tape over that wire and over these wires in like a little bit of a U-shaped pocket. So that way when this engages, it doesn't look like they're near it, because this sits sort of, what is that, like 2 millimeters below the lip of the box, and those are much lower. But just in case something moves, I wanted to have something between wiring and this lid, and so I use this Tessa tape, which is pretty good for stuff like that. And so we now sit this, and we can feel a bit of compression happening, and that is what we want. So that way, when this thing is completely screwed down, it is a slight compression fit for the battery in the box. So let's go ahead and do that. What I will try to do is get a couple of screws going, and then have that sort of tack the lid down. Then we can turn the whole thing over and then get the rest of the screws in. The screws come in from the bottom, and a couple of them are like up against the wall of the box. That's kind of awkward to work with. So we've got all the parts here now, and we've got the Superflux V2 high speed with the large Burris tire. We've got the axle blocks. We've got the core assembly, the guts kit as it were, and we have these beautiful Tech Rails 357 extendos or whatever. These are used, but they're still in pretty good shape, and they are extended. And so this is what we're doing. This is what we've got going on here. And so that's what's going to happen. I'm going to go ahead and just, not so much time lapse, but high speed video rather, through this. And all the parts were kind of mentioned before. We'll be using the titanium bolts, because these are the extended ones. These are standard GT bolts. You can see the extra thread length here. Let's zoom in so you can see that. So you can see that these are indeed longer, and that is important for the Superflux, since we are going through the block into the axle. So, and I've gone ahead and applied the Vibratite VC3 rather than using the regular blue Loctite. So that way, when this thing goes in together, it'll just go ahead and hold the threads. We'll torque it down, and then we'll be good to go. And this color combination is going to look pretty nice, I think. Got some bang bumpers over there with the black and white swirl. And so, as I said, I'm just going to go ahead and, like, a speed run the assembly through this, so that way we can get it put together and set up and configured today. And that way my friend, my local friend and colleague, can go ahead and take this with him on his upcoming trip. So let's go. that was your ordeal. So this is done. Not set up yet, but we will set that up momentarily. Oddly enough, the screws that came with the Tech Rails fender delete were soft garbage, and so they are in the garbage now. And I hope to never see screws like that again. That's embarrassing for a high-end vendor to send out fasteners that are made of pop metal or Play-Doh or whatever the hell they are. Doesn't matter. The last thing to do is take the stock GT charger, harvest this connector plug, because this is the gold right here. So on a stock GT charger, there's a PCB in here that converts the output voltage down to a lower voltage on a scale, and that communicates with the BMS. We don't need any of that. We only need 2 of the 3 pins here, and they match up with the 2 of the 3 pins on this charge port. And so we're going to cut it right about there, create a bit of a dovetail connector, most likely going to use an XT60. That way this can be attached to other chargers. So this runs at 84 volts. This charger is 75.6 because this board is 20S, the GT is 18S. So this plug does work at 20S without issue because 2 of the pins are just straight up output voltage of the charger. Cut that, dovetail it, get an 84 volt charger and use this as the adapter so we can charge this board up to full and then run through configuration and testing. So exciting.